According to Euclid, who was an ancient Greek mathematician in Alexandria, the law of nature are but of the mathematical thoughts of God. Hi everyone! I am Aiya M. Fernandez from class G47881, which is the Mathematics in the Modern World. So in this video, we'll talk about geometry, or to be more specific, we'll talk about geometric designs. So when we hear or think about the word geometry or geometric designs, what comes into our mind? Well, initially, when we hear the word geometry, we think about formulas, we think about numbers, and of course, we also think about shapes. But the definition of geometric designs transcends to that. When we say geometric designs, it is a branch of mathematics and art that focuses on creation, analysis, and also the application of shapes, patterns, and spatial structures. Geometric designs hold a crucial role in everything that we see, from the buildings we live in unto the technologies that we use in our everyday lives, such as our cell phones and laptops. It is a field of mathematics that combines mathematical precision, spatial reasoning, functionality, and of course aesthetics to create efficient, but not just that, beautiful structures as well. Geometric designs has various of aspects, but for this video, we'll only tackle about one aspect of geometric designs, which is the study of solids. But before diving deep into the study of solids, let's first have a quick recap on the study of polygons. So polygons are flat-shaped objects that have straight edges, and of course, it is two-dimensional. So have in mind that polygons are two-dimensional objects. So solids in geometry are three-dimensional objects that occupy space and have volume. Every solid has surfaces, edges, and vertices that defines its shape. Surfaces are the outer part of the solid, which can either be flat or curved. For edges, this is the line where two surfaces meet. And for the vertices, this is the point where two edges intersect. So these solids are classified into two major categories, namely polyhedra and non-polyhedra. And we'll discuss them one by one. First, let's go to polyhedra. So polyhedra, or in singular form it is called polyhedron, are solids with entirely flat polygonal surfaces with straight edges and straight vertices. Also, we have this formula for our polyhedra, which is called the Euler's formula, which is F plus V minus E is equal to 2, where F stands for faces, V stands for vertices, and of course E stands for edges. So this formula applies exclusively to those shapes or objects that lack any holes or any self-intersection. Now let's move on to having some examples. So we have here examples of polyhedra, which are categorized into three categories that we will discuss one by one later on. But for now, let's have the first category, which is the platonic solids, which are regular polyhedra. Number one, we have a cube. So a cube has 6 square faces, 8 vertices, and 12 edges. So where are the square faces here, the vertices, and the edges? So I'll discuss it to you guys. So first, we have 6 square faces. So if the cube is being spread out, this is its image. So these are the square faces. So when we say faces, or when we say polyhedra, we must remember that it is made up of entirely flat polygonal faces. And as we can remember, square is an example of a polygon. So it's a two-dimensional shape. So a polyhedra is composed of polygonal faces. So we have square in this example. So we have how many faces? We have 6. So this is 1, this is 2, 3, 4, 5, and 6. Now let's move on to our second example. We now have the shape tetrahedron. So a tetrahedron has 4 triangular faces, 4 vertices, and 6 edges. So these are its triangular faces. So we have 4, 1, 2, 3, and 4 at the back. For its vertices, which are the points that intersect, we have 4 vertices, which is 1, 2, 3, and 4. And for the edges, we have 6, which are the lines that the two surfaces meet. So we have 1, 2, 3, 4, 5, and 6. For number 3, we now have octahedron. It has 8 triangular faces, still triangular faces, 6 vertices, and 12 edges. So we have 4 in front and 4 at the back. So 1, 2, 3, 4, and 4 at the back. So they are the 8 triangular faces, and we have 6 vertices, 1, 2, 3, 4, 5, 6 vertices. And of course, the edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this is an octahedron. Let's move on to our 4th example, which is a dodecahedron. It has 12 pentagonal faces. So for this one, from our previous examples, the faces that they have are triangular faces. But for dodecahedron, we have pentagonal or pentagon. So we have 12 pentagonal faces, and 1, 2, 3, 4, 5, 6. Yeah, 6 at the top and 6 at the bottom. So we have 12 pentagonal faces, 20 vertices, and of course 30 edges. So for our polyhedra, we must just memorize, or for solids, we just have to be familiar with the words of the 3 key components of polyhedra, which is faces, vertices, and edges. So again, when we say faces, these are the fully, entirely flat polygonal faces, and the vertices are the points where 2 lines meet or intersect, and for edges are 2 surfaces that the line where 2 surfaces meet. So we just have to be familiar with those terms so that it would be easy for us to understand and identify such shapes. So let's go I think this would be the last example for the platonic solids in regular polyhedra. So we have icosahedron. We have 20 triangular faces, 12 vertices, and 30 edges. So these are some examples, or these are some representation of what icosahedron is. Now let's move on to the second category of polyhedra, which are prisms. What are prisms, by the way? Prisms have 2 identical bases and rectangular side faces. So let's have an example. For this one, this is what we call rectangular prism or cuboid. So this has 6 rectangular faces, 8 vertices, and 12 edges. So a real life example would be a shoebox and bricks. And so yeah, these are the identical bases. So the identical bases here are 2 squares, and then the sides are rectangular side faces. So again, for us to identify what prisms are, prisms have 2 identical bases, for which in this case we have 2 identical bases, which are 2 squares, and we have rectangular side faces, which are these ones. So we have 6 rectangular faces in total, 8 vertices, and 12 edges. Moving on to our 7th example, or the second example for prism, which is a triangular prism. We have 2 triangular bases, which is this first triangle and this second triangle, and 3 rectangular faces, which is 1, 2, and 3 at the bottom. And we have 6 vertices and of course 9 edges. Some real life examples that we will see in our daily lives would be chocolates, which is an example for this would be Toblerone, and of course tents. So they have identical bases, which is triangular bases, and we have 3 rectangular faces. So that is what we have to remember when we say prism. 2 same or identical bases and that have rectangular side faces. The third example for our prism would be pentagonal prism. So we have 2 identical polygonal faces, which is pentagon, and then we have 5 rectangular faces. So this is our base, this is our second base, and these are our rectangular faces. We have 1, 2, 3, 4, and 5. 2 pentagonal bases, 10 vertices, and 15 edges. So when this image or this shape is spread out, it would look something like this. So these 2 are the bases, and these 5 is our rectangular faces. So which makes it a prism. our fourth example for prism and our ninth example for polyhedra, we have hexagonal prism. When we say hexa, it has 6 sides. So we have we have 2 hexagonal bases. This is our polygonal face for this shape. So hexagonal bases and 6 rectangular faces. So this is our example. And let's move on to the third and the last category of our polyhedra, which is the pyramid. So what are pyramids? They have a single base and a triangular faces that meet at a vertex. So this is its vertex. No? It's a point. So what is the single base of this pyramid? Of course, the single base of this would be a polygon, which is a quadrilateral or a square. So it has a single base and triangular faces. For this case, we have 1 square base, which is this one. It should be base. 1 square base, and of course, 4 triangular faces. 1, 2, 3, and 4, 5 vertices, and 8 edges. Now that we are done with the first category of solids, which is polyhedra, or in singular form, it's polyhedron, let's now move on to the non-polyhedra, or in singular form, called non-polyhedron. What is a non-polyhedron? It is a three-dimensional solid that has at least 1 curved surface and does not consist entirely of flat polygonal faces. So in this case, the Euler's formula is not applicable because the standard of Euler's formula, it is only applicable exclusively to those shapes that lack holes. And lines, they do not consist lines that intersect with each other, or self-intersection. So, again, the keyword for non-polyhedra is the word curved, or the term curved surface. At least one curved surface. So now let's hop into some examples. First, we have a sphere. This is the basic one. This is a perfectly round shape. So it's a perfect round shape. So we have some real-life world examples. We have some basketball, volleyball, tennis ball, some billiard, and marbles. Next is a cylinder. So this is considered a non-polyhedra because, of course, it has a curved surface. So it has 2 circular bases. It's a 2 circular bases. We have 2 circular bases, and it has a curved surface, which is this one. This is the curved surface. So an example for this in our real world time, we have cans, soda cans, and of course, pipes. Let's hop into the third example. The third example would be a cone. So a circular base tapering to a point. So this is its point. This is its point. So based on my research, this triangle should be a 90 degrees angle, so that just imagine a regular triangle or a 90-degree triangle, and then you taper it together. So you meet the other point to the other point, and it would become like this. It would come up with a cone. So that is what a cone is. So it is curved. That's why it is considered a non-polyhedra, or a non-polyhedron shape. Next, you have torus, which is basically a donut-shaped solid. So basically, it just looks like a donut. So we have examples here. We have saving device, and we have donuts, and of course, bagels. So we see them in our everyday lives. Fifth, for our non-polyhedra example, we have an ellipsoid. It is stretched or squashed sphere. So as we can remember, sphere is really a perfectly round shape. So it's a perfect round shape. But for our ellipsoid, it is, just imagine a sphere being stretched or being squashed. So that is the difference between a sphere and ellipsoid. Next is a hemisphere. So sphere is a complete and perfect round circle, while the hemisphere is just the half of a sphere. So let's not be confused with those two. So a sphere is a whole, an entire, and a perfectly round shape, but the hemisphere is just a half of a sphere. Going on to our seventh example, we have the paraboloid, which is the curved shape which is often found in antennas and telescopes. Number 8, hyperboloid. It is used in cooling towers and some modern architecture. So these are example of cooling towers and some modern architecture. So as we can see, it has still bases, and then this is its curved body or curved face. Let's go on to our ninth example. We have the capsule. So a cylinder with hemispherical ends. So this is its hemispherical ends, and still same with the cylinder. However, this possesses a hemispherical end. So, of course, an example for this would be medicine or capsule. Last but not the least, we have frustum, which is a cone with the top cut off. So, if we can remember, this is our cone, so we just imagine that the top is being cut off. Okay? So that is what we call a frustum. So a real-life world example would be a lamp and a pail. So as we can notice from all of our examples, all of these shapes are really evident, and we really see them every day as we continue to live in this world. So 3D is everywhere that we see. So you see the solids, geometry and geometric designs is not just about shapes or formulas or numbers. It's everything. It's about everything that we see in our daily lives. So let's move on and let's have a table of comparing polyhedra and non-polyhedra for us to have a clear definition or clear differences between the both of them, so that we would not be confused and we would know how to identify a shape. Is it a polyhedra, or is it a non-polyhedra? Or is it a polyhedron rather, or a non-polyhedron? So let's talk about surfaces. So when we say surfaces, in polyhedra, it is flat, so it is with polygons. However, in non-polyhedra, we work with at least one curved surface. So that is really the main difference of the both of these. This is the main difference of them both, rather. So polyhedra is flat, or consisting of polygons, while non-polyhedra consists of at least one curved surface. For its examples, we have cube and tetrahedron, which is, again, composed of flat polygons. And for non-polyhedra, we have sphere and cylinder, which consists or which possesses curved surface. For its edges, the polyhedra is straight, but for the non-polyhedra is curved. For its faces, again, polyhedra works with polygonal faces, but in non-polyhedra, it can be circular or curved. And for real-world uses, we can see polyhedra in crystals, in buildings, in school, even our houses. And for the non-polyhedra, we can see them in balls, pipes, and domes. Now we are finally done with the two categories of solids, which is polyhedra and non-polyhedra. Now let's move on to geometric designs in different fields. So how we can see geometry in our everyday life. So first, in architecture and engineering. So we can see geometric designs in various fields. So first is architecture and engineering. For example, the Great Pyramids of Egypt, which is based on a square pyramids for stability. So if you can remember, where does this belong? Square pyramids. Is it a polyhedra or non-polyhedra? That's right. It is. It does belong to polyhedra. Why? Because it only has flat surfaces or polygonal faces. One square base and four triangular faces. So next is geodesic domes, which utilizes triangles for strength and efficiency. And third is for bridges, so which utilizes triangular frameworks for load distribution. So just imagine a world where we don't have any knowledge about geometry, wherein architects and engineers could not comprehend or could not understand the basic context or the basic content of what geometry is. So it would be definitely difficult and challenging for them to come up with these infrastructures that is truly helpful and that we could all benefit from. Second is graphic design and art. So just like logos. So companies like Adidas that utilizes triangles and Google Chrome, which is circular and polygonal shapes, use geometric patterns. So in geometric design, we do not only see them in infrastructures or structures, but we also see them in businesses. So they help businesses to thrive just using geometric designs. We have also mandalas, which is found in many cultures. They use circles, triangles, and symmetry for spiritual and artistic purposes. And third is we have pixel art and vector graphics, which utilizes geometric grids for precise digital images. So of course, in our everyday life, or even in whatever aspect of our life, there is a need or there is a great necessity for precision, which geometric designs provide. Third is, of course, for industrial and product design. We have honeycomb packaging, which uses hexagons to minimize material use and maximize its strength. So a lot of pros, a lot of positive benefit from geometric designs. And next is smartphones and laptops, of course, that smartphones and laptops that we use in our daily life, even as a student or a worker or just a normal citizen of our community. Designed using rectangular prisms for efficient space usage. So sports and equipment, of course, where soccer balls are based on truncated icosahedrons or hexagons and pentagons. Let's have our fourth field, which is the nature and biology. For example, in snowflakes, we see geometric design in snowflakes because it exhibits a hexagonal symmetry due to a molecular structure. Next is the turtle shells. It is formed with hexagonal patterns for its structural support. So it is not just for aesthetics, it is not just for the look, but it provides structure and support and strength to the turtles. Third, we have spiral shells. It follows the Fibonacci sequence and growth pattern. So wherever we go or whatever we do, we really see mathematical concepts everywhere in this world. So we have our fifth example, or our fifth field, which is the technology and digital applications. We have 3D modeling in video games. Characters and environments are created using polyhedra and meshes. So what are the video games that we are familiar with today? So we have Mobile Legends, we have Call of Duty, and so much more. Next, we have AI pattern recognition, which is really rampant in today's world. AI pattern recognition uses geometric principles to detect faces, objects, and movements. So this is even useful. Is the feature in our cell phone familiar to you? For example, let's have, for example, an iPhone. So an iPhone already has a finger recognition and a face recognition, which we can which utilizes geometric designs. Amazing, right? So we also have satellite dishes and telescopes. We use in this field, we use parabolic shapes to focus signals efficiently. So they really have their intended uses. So every shape has its intended uses. So, lastly, let's talk about why do we need or why is it necessary for us to study geometry or geometric designs? Of course, we are in need to study these things because, of course, as I've mentioned a couple of times already, geometry and geometric designs, we see it every day. We see it in our daily lives. So it would be helpful and it would really benefit us if we know or we have a proper knowledge about these things so that we can identify and we can understand how the world works. Number one, we have foundation of mathematics and problem solving. It enhances logical thinking and spatial reasoning. This is really important, not just for students or workers, but for every citizens as well. Next is we have essential for engineering and architecture. Of course, an example would be myself. So I am an engineering student, which is really important for me to learn about these things. So why? Because it ensures stability, efficiency, and aesthetics and structure. So as I continue to study my course, so this is a very an important topic because soon when I graduate, I'll have to understand how geometry works and how it really works in our real life world. since we will not be dealing anymore with some just papers. We are really dealing with structures that could either break or make the community. 3 is practical applications in daily life. So it helps in measurements, designs, and understanding everyday objects, like how does our cell phone works, how does light works, or how does many things work, no? In engineering and architecture, in every aspect or any field of our life. Number 4 is technology and innovation. Powers 3D modeling, robotics, and of course, again, AI pattern recognition. 5 is of course not only for structure, it's not only for efficiency, but it's also, of course, for the appearance, aesthetics, and art. Used in graphic design, fashion, and architecture for visual harmony. Because, of course, as human, we are really beings who really want pleasure in what we see. So it is useful in aesthetics and art. That is why we need to study geometry. 6 is understanding nature, of course. Explains patterns in biological growth, planetary movements, and natural structures. For example, we have waves which create patterns. We have butterflies, we have flowers, we have many animals and many plants. And we also have hurricanes or typhoons. They still have these patterns, and studying geometry would help us understand those things. Last but not the least, why do we need to study geometry? Because it enhances critical thinking and our creativity. It encourages innovative problem solving and efficient designs, which helps every one of us, the policymakers, the government, the scientists, all of the people in our community. It helps each and every one of us to create more innovative structures and infrastructures that would really benefit the whole community. So this would be an encouragement for us to continue studying geometry or geometric design. So again, geometric designs or geometry is not just about formulas, numbers, or shapes. It is more than that. It holds a crucial role in our everyday life. So again, I am Aiya and Fernandez, and thank you so much for watching. I hope that you learned a lot. Thank you, and God bless.